In lesson 2.3 Cooldown, the first question we're asked is to write an equation which has the following features. So first of all, they tell us the degree is 5. That means I must have an x to the 5th somewhere in there, or as the highest exponent. They also tell us it has to have 4 terms, which means there must be 4 separate pieces that are being added or subtracted together. Then they also tell us that it must cross the vertical axis at y equals 12. Well, that means my y-intercept must be 12. Or in other words, the graph must go through 0, 12. So we can do this pretty quickly here. I must start with an x to the 5th term. Doesn't matter what's in front of it. Could be a 2, could be a negative 10. Doesn't matter. I must have 4 pieces. And in order to have my y-intercept be 12, I know that it must end with a plus 12 at the end. So I can fill in whatever I want in the middle, actually. X to the 5th minus 6x squared plus 99x plus 12. That'll work. You can test it out on a graphing calculator or a Desmos. Lots of other options there, but that'll work. Second question, identify the approximate input values of any relative maximums and minimums of this 5th degree polynomial. So we defined these in the first part of this lesson, relative maxes and mins. We haven't talked about them a lot since then, but here they are. So relative maximums, I'm going to do those in blue. So I'm looking at the graph and I notice, boom, there is a relative maximum. And that has an input value, so that means x value, an x input of about negative 3.3. I notice right here, another relative max, another top of the hill. Well, that one looks like it crashes right at x equals 1. So my relative max there with an input value of 1. If I scan along the graph here, no other relative maxes, no other tops of hills. If I look for relative mins now, so those in red, I notice a bottom of a hill or bottom of a valley right there. That's really close to negative 1, but I'm going to call that negative 0.9. And then I notice if I scan along, there's another bottom of the hill right here. Let's see, what's my input value there? Looks pretty close to 5. I'm going to call about 4.9 though. X equals 4.9. And they said approximate, so this is fine. But again, we estimated the input values, the x coordinates, for all of our relative maximums and all of our relative minimums.